Science is responsible for most of the good things we see around us. Oh, I had that a lot. But it was difficult in school to relate what I learned in the classroom to these supposedly good things in the world. However, for the past 5 years, I attended Northwest-University, finished my bachelor's and honors degree, and I'm now busy with my master's degree in environmental sciences and management of air quality. Here I've learned firsthand how science, technology, engineering, and mathematics are changing the world for the better. I'm Simon Dlangamandla Moletsane. This is my story, and today I want to share it with you. I grew up in Sharpeville, a township that is informally known as Shavers or Swingsters, just like other people might call it. This vibrant community is in the heart of the South African industrial area. Like most townships, it's sometimes a dangerous place, but the biggest killer, it is invisible to most of us. It is the air that we breathe. Now you might think I'm referring to the big plume that comes out of the factory's chimney. Industries contribute, yes, but most of the time, what you see is actually steam. Many times, air pollution is invisible to our senses. Air pollution is all around us, and the activities that create air pollution are everywhere, even in your home. Of all the things that wants to kill you in South Africa, we think air pollution it is the biggest one that you alone cannot control. You can decide to eat healthier, to be active, and to stop smoking. But most of the time, you alone cannot change the air that you breathe. Your risk of having health impacts from exposure to air pollution in your home and in your community is much more bigger than from a gangster. We estimate that more than 75 people in South Africa die prematurely daily because of air pollution. How does that compare to murders in South Africa? 58 people per day? The impacts of air pollution on health cost our economy the same as almost double the annual contribution of agriculture. If you think I will scare you with statistics, don't worry. I actually want to tell you how science is addressing one of the biggest environmental problems of our time. I want to show you the technology we use to study air pollution. We will talk to the local experts. Through this, you will see how science is shaping the policy and ensuring the constitutional rights of the people in South Africa. So what exactly do we mean by air quality? Let's listen to what one of my supervisors said in an interview with ENCA.
It has an impact on all aspects of health. It restricts your respiratory system, and that leads to all the typical respiratory problems and aggravates existing respiratory problems. But it can also then cause a strain on your heart, so there's a range of cardiovascular problems, and then there's also some suggestion of cancer. So it has an impact on the whole suite of health problems.
The air that we breathe impacts our health if it contains high concentrations of small particles or toxic gases. It aggravates the existing health conditions or causes the underlying unknown ailments like respiratory diseases, for example, asthma, and cardiovascular diseases like strokes. Although many different types of pollutants in the air impact our health, it is small particles that have by far the biggest health consequences. The size of these particles has to be extremely small to enter into the lungs. They have to be as small as 2.5 microns, which is as wide as 1/10 the width of one of your hair. We generally refer to these as fine particulate matter, or PM2.5. Because of their small size, they are mostly invisible to the naked human eye. People's health is impacted as soon as they breathe PM2.5. High concentrations have acute impacts, even at short time. You will immediately feel the impact of high concentration of fine particulate matter in the air. Your nose and your eyes might be irritated, and you will have difficulty of breathing. Very serious episodes of air pollution during 1952 in the United Kingdom, London, were one of the first to show the direct link with health impacts. Let me show you what happened during one of the best documented cases of a severe air pollution event. I will plot the data on a time series graph. The x-axis represents time. You will see the first 15 days of December 1952. On the y-axis, we put the concentration of the pollutants. This is the weight of the pollutant per cubic meter of air. The weights are in microgram. 1000 microgram is 1 milligram. This is the most common unit we use for pollutant, microgram per cubic meter. Now, let's plot the concentration of sulfur dioxide and the smoke for this period. We put a marker for the mean daily concentration of each day and connect them with a line. These two pollutants are emitted when one burns coal, which was very common in London in the 1950s. In South Africa, coal is one of the predominant energy sources. We use it for more than 90% of our electricity, and many households use it for cooking as well as heating. At the time, they did not measure fine particulate matter. You can see the sudden onset of the event on the 4th of December. This was caused by weather conditions. Stagnant air and fog combined with bad air quality to form this smog. Look at some photos of the time. Now if we plot the number of the daily deaths in London at the time, you can see the correlation. We plot the deaths on the y-axis on the right just to remind you that it is different units. Almost 1,000 people died at the peak of the event on the 8th of December. Today, we estimate that about 12,000 people died because of this one period of bad air quality. Although it was not clear at the time what the direct cause was, the association between deaths and bad air quality is clear. As air quality deteriorates, more people die. The impact also lingers after the conditions improve. Let's add the guidelines in the red that the World Health Organization uses for larger particles. You can get an idea of how bad things were. Today we have very good evidence of these links. We also know that chronic exposure to even lower levels of fine particulate matter can have disastrous impacts on health. The people who are mostly at risk of chronic diseases resulting from such exposure are elderly, young children, and people with existing respiratory and/or cardiovascular diseases. We estimate that 1 in 8 deaths in the world are from air pollution. A new study says that more than 10 million people could be dying worldwide every year because of bad air quality. Let's see what members of the public think about air quality. What do you think are the biggest environmental challenges that we as the residents of Sharpeville are facing?
One, pollution.
Air pollution.
Air pollution. It kicks quick because without air, there's nothing you can do.
Air pollution.
Because nobody's dealing with the stats.
The air that we are breathing is not okay.
The air we breathe, it's not pure.
It's not pure.
Yeah.
It's too harmful, my man.
We breathe gases.
So what are the causes that make the air that we breathe not to be clean?
Pollution,
But what causes pollution?
sewage, us dumping papers.
Burning tires.
Hey man, there are many men. You know many men.
goba di tletse di tshola di tja ho etswang ha ona ntho e right e tshelwang mo.
You would find people burning tires. After doing my garden, I'm burning my grass.
Mehleng ya pele Sharpeville ne le sekolo. E ne e sena ditoti tsena, e sena ntho tsena. Mare jwale morao tjena ba sa ba iketsetsa boithatelo.
What are some of the solutions you have? Like, what do you think we should do in order for us to solve the issue of air pollution in South Africa, in Sharpeville?
Yeah,
I think we should raise an awareness.
Because once the people know what is happening, surely the people are not going to allow all this operation to happen.
Take measurements.
we should make a debate about air pollution.
And if there's anything that science can do to minimize the damage that all this pollution is causing, I mean, look, I'm thumbs up for it.
Stop dumping papers everywhere we go.
We have to have knowledge where it started and then understand the activities and do so.
And it all comes back to science. Yeah.
Let's think about the different things that we humans do that contribute to bad air quality. We extract raw materials like coal from the ground that leaves huge man-made mountains of dust that get blown into nearby communities. We burn coal to generate electricity. We manufacture metals, ceramic, and plastics. We refine fossil fuels into petrol and diesel for our cars. We develop consumable products like food and retail. We disturb the Earth's surface to grow food and to build communities, leaving the bare areas where dust can be blown into the air. We burn dried grass in our towns. We burn waste in our communities. We play sport on fields that lack proper infrastructure. We burn wood and coal in our homes to keep us warm and cook our food. We pack millions of people into townships where all these activities together aggravates the problem.
This area is declared the Vaal Triangle Airshed priority area because it is a complex problem to resolve. We have multiple sources of pollution in this area and the problem is a complex one. There are different sources, so we need a complete methodology to understand what the sources are. There is industry, we know that, and they have a lot of different types of pollutants that are being emitted from there at very high level, but huge amounts of emissions being put into the atmosphere. But we also have ground level sources, which would be your waste burning, domestic burning of dirty fuels, and even activities walking around in where there's no grass that has been planted. The wind-blown dust is a big contributor to pollution as well. And then there's mining as well, which is a hugely unabated source of pollution. We cannot just decide on solutions sitting on our desks in offices and anywhere. We need to be on the ground to understand what the problem is. It is a complex one to resolve. That is why we have to do source apportionment studies so that we can understand what the major sources are, what is the actual component of the pollution that gets to the people. That's why we have the source apportionment studies, so that we don't just dream up solutions that cannot be influenced by the science on the ground as to what the problems are. And then once we understand the problem in great detail, we then develop new interventions for the second generation of the air quality management plan that will look to reduce the problem from all the major sources that we have in this area. People need to be supplied with clean fuels to heat their homes and to cook in their homes, as well as the waste needs to be collected and the waste burning within communities need to come to an end. We need to therefore in this project understand how much of a reduction is needed from all these sources. South Africa is a unique community. We have to design unique solutions for the unique problems that we have. As such, we are going to develop this second generation air quality management plan. We've started. We're just waiting to complete the source apportionment project and all the science that we are putting into it to ensure that we understand the contributions and we therefore design interventions for each one of the sources that we have understood in great detail.
Now that we understand what air quality is and how we would like to manage it, I want to show you how science, technology, engineering, and mathematics can help us to address the problem of air quality, many of which I also use in my own research. In the next segment, I'll be interviewing my study supervisor, Professor Stuart Pickett, the director of the School for Geo and Spatial Sciences, on how we use physical sciences to identify the contribution of different pollution sources to air quality. He has applied the scientific methods that we will discuss to answer many air quality questions in South Africa. We will recognize many of the underlying principles we use from your high school classroom. Good day, Professor Pickett. How are you doing?
Hi, Simon. Nice to see you.
Nice to see you too. Thanks for your time and for allowing us to have this gracious interview.
Take a seat, Simon.
Thank you very much, Prof. So, Prof, you have dedicated your life in ensuring that South African people do understand that air pollution is a very complex subject and there are different many sources that contribute towards air pollution. So the first question that I have for this interview is, why is it so important for us to understand the different sources that contribute towards poor air quality?
That's a good question, Simon. So air pollution is a very complicated problem, and it's complicated because lots of factors contribute. On the one hand, we have industrial sources. So if you drive past the big power stations, you drive past the big chemical processing plants, the heavy industry. However, at the same time, if you drive past homes where they're burning coal or wood to heat their homes or to cook on, there's emissions coming out of those little chimneys. Parts of the felt that don't have any vegetation on, have dust which gets blown off the surface and into the atmosphere.
Can you perhaps show us some of the observations which you've made in your past experiences regarding the contribution of different sources to air pollution?
Sure. So what I've got here on the map on my screen here, Simon, is an example of where we've been taking measurements in the Vaal Triangle. We've got 4 sites that we monitored, and we measured those, and this is the type of measurements that we are making and examples of the monitoring stations. So in my first diagram here, my graph, I've got a stacked chart which effectively shows all the sources that contributed in the Vaal Triangle to the coarse fraction, to those bigger particles. So you can see that the orange part of this graph, for example, shows that between 30 and 40% of the particles that we measured were really from dust, wind-blown dust, you know. Then we've got sulfates, we've got motor vehicles, the dark blues, and we've got emissions from coal combustion. For example, coal combustion from the big industries. We know in the Vaal Triangle we've got industries that use coal. Now if we look at the very fine particles, the particles that really get into our lung and cause us lots of health problems, the light blue area on the bottom, that really shows us a complicated process in the atmosphere where emissions into the atmosphere in the form of gases convert in the atmosphere to small little particles called sulfate. And the blue portions here are basically showing us, for example, the sulfate. Now that sulfate has implications for our health, it has implications for the weather, it has implications for the climate. The other important source that you can see here again is burning of wood, burning of waste, burning of coal. So you can see in the Vaal Triangle a complex situation of different sources contributing to poor air quality in the region.
So, Prof, thank you very much for your time and for sharing your knowledge with us. We really appreciate it. Thanks, Prof.
Thanks, Simon.
Professor Pukke spoke about how important it is to know the contribution of different pollution sources to air quality. It is not as difficult as you might think. Let me show you how we do this. We want to capture the particles in the air by drawing it through a paper-like filter. We want to weigh the filter before exposing it to the air at the site where we want to make the measurement. Remember that the small particles will weigh extremely little, about 1,000 times less than the smallest little feather on a bird. We therefore need a very accurate scale and a lot of patience. The first variable we want to remember is the initial weight of the filter. This one weighed 186,064 micrograms or 0.18 grams. The location of the site is extremely important. The methods we are discussing will answer the question, what air pollution sources contribute to the air quality at this particular site for the duration that we expose the filter? We put the filter in a holder, then pull air through the filter using a pump, while carefully measuring the total volume. The volume of air will be important to change the total weight of the particles that accumulate on the filter into a concentration. The pump in the instrument draws air through the filter at a rate of 5 liters per minute. We typically draw air through a filter for a whole day. That will come to 7,200 liters. Remember that we like to present the volume in cubic meters. To do the conversion, we just need to remember that 1,000 liters make 1 cubic meter. So in 24 hours, the pump will draw 7.2 cubic meters through the filter. When we study a site, we expose different filters for many days. We need enough samples for the site so that we can say with confidence that the weather conditions we experienced were typical for this time of the year. After we have exposed the filter at the site, we bring it back into the lab to get the weight of the particulate matter that collected on it. You can see how the color of the filter has changed. It is caused by all the small particles in the air that were sucked onto the filter. The difference between the final weight and the initial weight before exposure equals the total weight of the particles in the air. The final weight of the filter was 186,302 micrograms. The weight of the fine particles on the filter is 238 micrograms. To get the concentration, we divide this weight by the total volume of air that was pulled through the filter, which was 7.2 cubic meter. The concentration is the number that tells us if the air is safe or if we can expect health impacts. Remember PM2.5, the concentration of fine particulate matter in the air? Well, this is what we just measured. We now know what the level of PM2.5 in the air is, but we still don't know where it comes from. The rest of the methods will try to figure that out. After we have weighed the filter, we want to know what the chemical elements of the particles are. These are the same ones you find on your periodic table of elements in your chemistry textbook. Since we know what the typical elements are in the different air pollution sources, we can then use that information to estimate their contribution to the observed concentration of PM2.5. For example, in dust, we expect elements such as silicon, aluminium, iron, and calcium. For domestic fuel and waste burning, we expect chlorine and potassium. For large industrial sources, we expect sulfur as well as ions like sulfate, ammonium, and nitrate. If we analyze the filter and determine which elements are present in their concentrations, we can compare that with our knowledge of the chemistry of the sources. We use an instrument called X-ray fluorescence spectrometer. It shoots X-rays through the filter and measures the resulting energy release. This energy is related to the structure of the atoms. Each element has a unique signature. The resulting energy release of the atoms in the particles therefore tell us how many of the different elements are present on the filter. For each filter, we end up with a table showing weight contribution of the elements. We have done this analysis for Sharpeville. Let me show you a pie chart of the sources that contribute to fine particulate matter, PM2.5, on the left, as well as slightly larger particles, PM10, on the right. In Sharpeville, we see industry, coal combustion, domestic and waste burning are all important sources that all contribute to PM2.5. For larger particles, traffic and dust sources are also important. We now know what are the activities that contribute to bad air quality. If we are looking to clean up the air, we need to find ways to limit the emissions from these sources. Next, we can see how technology plays a role in studying air quality problems. Let's hear what Gerard Botha had to say about his work on instruments that can make real-time measurements of PM2.5. He's an intern with the Climatology Research Group at the Northwest-University.
Hey Gerard, it's nice seeing you, man. How are you?
Simon, I'm good, and you?
I'm good, man. I just want to show the people the types of instrument that you're working with on daily basis. So can you please tell us more? What is this instrument of yours?
Sure. So this instrument is quite similar to the one you use, except it works on the light scattering principle, which uses a laser. So as you can hear, that sound you're hearing is a pump. So the pump draws in the air, and then the particles scatter the laser, which we translate into a measurement so that we can know what kind of pollution there is. And we especially look at fine particulate matter, just as you do.
So you've made the modification of the instruments, right?
Yes, we do. So what I've done is, we get this instrument, but then I connected it to this box together with the wind sensor so that we can know from which direction the wind is coming. So what I've done is, I use this little computer known as a Raspberry Pi to log and store the data and also send the data to a computer on campus using a programming language known as Python. And this dongle, this internet dongle, provides this Raspberry Pi with power and with internet so that we can send the data to the computer on campus.
The South African government uses similar instruments to Gerard, just a bit more expensive, to make measurements of the air quality all around the country. One of these stations is situated at the Northwest-University Val Triangle campus, not far away from my home in Sharpeville. There is another one at Tutolore Secondary School, also in Sharpeville. There are more than 100 of these air quality monitoring stations in South Africa. You can see their data on the free app. Just search for SAAQIS. The quality of air is indicated using different colors. Green is good and red is bad. They measure our old friend, PM2.5, and also made the other gases that also impact health and the environment. These include sulfur dioxide, nitrogen dioxide, and ozone. Government uses these observations to identify problem areas and to see if our efforts to improve air quality are working. I've also downloaded the daily average fine particulate matter for Sharpeville from the South African Air Quality Information System website. I use the same axis as before, time on the x-axis and concentration on the y-axis. I chose a year where we have a lot of data available and where things are not complicated due to the COVID pandemic. We see concentrations are worse during winter when it is cold and there is less rain to clean the atmosphere. If we add the World Health Organization guideline as a red line, you see that the concentrations are at unhealthy levels for a large part of the year. Engineers play a very important role in developing solutions to the problems of bad air quality. They use science and mathematics to solve problems. We now know that we need to find solutions to air pollution sources like large power stations, industry, and domestic burning. Engineers at the Northwest-University are working on these problems. Marcus is a chemical engineering student that is working on ways to remove sulfur dioxide from industrial stacks. This is one of the undesirable gases that form when you burn coal. While it is bad for your health at high concentrations, it also converts into fine particulate matter in the atmosphere. We call it secondary particulate matter sources when we looked at the pie chart of the sources contributing to air quality problems in Sharpeville. You will remember that it was a significant problem.
Okay, Simon, here's the experimental setup I was telling you about. So what this project basically focuses on is reducing industrial emissions from toxic gases that are emitted by industrial complexes. Looking at this experimental setup, the toxic gases come in from feed pipes here, where it moves to an oven inside a reactor where it reacts with some solids to reduce a less toxic compound.
So please, Marcus, tell us about how did you get yourself here? What were the subjects that you really enjoyed in order for you to find yourself here?
Well, Simon, at school I loved mathematics and science, and I wanted to use that in my daily life and try to improve the world in some fields if I can. Then I found out about engineering, and it gave me a way to do the subjects that I love as a job, but also to try and improve the world and make it a better place. And that's how I wound up here.
Thank you very much for your time, Marcus. Have yourself a nice day.
Thank you, Simon.
I mentioned before that South Africa relies heavily on coal to generate electricity. We have more than 15 large power stations that generate electricity by burning coal in a boiler to produce steam, which spins a generator to create electricity. Electricity is fairly affordable because South Africa has a lot of coal. However, there are huge concerns about the environmental impacts of this energy source. Engineers have developed solutions to take out fine particulate matter from stacks of power stations. Ronelle is working on one of these to see if she can make them better.
Simon, this is the technology that Marcus was talking about.
Okay.
So this is called electrostatic precipitation, and it is used to remove the fine particulates from the emissions of large industries. And how this works is we have a centrifugal fan. So it's just a fan driven by a motor that sucks air from the outside into the channel, and then it passes the air into this channel and through this section. This is called the electrode, or the ESP section, the electrostatic precipitation section. And as the air with the suspended fly ash passes through this section, it gets loaded. So we have a power supply that is connected to this support bar. It's a horizontal support bar. And as the ash particles gain a negative charge, the positively charged collection plates attract these particles. And then the particles sit on the collection plates. Therefore, or they are actually removed from the airstream. So then clean air exits the ESP section.
So Ronelle, tell us about the school subject that ensured that you are able to work with this fascinating abatement technology.
Well, there are a few subjects that actually played a role. So we have a bit of physics, obviously the electrostatic precipitation, Coulomb's law, and then we have chemical or chemistry, because we have to analyze the properties of the ash, because you have to go down to an elemental or a molecular level to see why is the ash behaving this way.
Ronelle, thank you for your time and for sharing your experience with us. See you in another day.
Thank you so much.
One of the problems in South Africa is the use of insufficient dirty stoves for cooking and heating in the homes of the poor. Not only does the insufficiency of these stoves force households to burn more fuels, it is the source of fine particulate matter. Many times, the stoves also cause very high levels of pollution inside people's homes. Unlike industrial sources that have tall stacks, these emissions are very close to where people live and breathe. In densely populated areas, this can be a significant problem. Vinru is working on a solution to this problem.
So here we have a coal stove which is specifically designed for low-income, poor communities. And what we're doing here is we're measuring the heat inside of the stove and the temperature, as well as the chimney emissions that goes out of the stove and into the atmosphere. So you'll see here at the back is thermocouples, which is temperature sensors, and this measures the temperature within the stove.
So Ventru, tell us, man, how does your research impact the society?
Well, Simon, we know that around the world, every year there dies about 4 million people due to indoor pollution. The research impacts society in 3 main ways. Firstly, we're reducing the indoor pollution levels that the people using the stove breathes in. Secondly, we're giving them an alternative way to cook and heat their rooms. And thirdly, and also importantly, we're also reducing climate change and emissions into the environment. So Simon, here we have the chimney thermocouples, we have the dust track line, we also have the 2 insulated lines, which is the gas analyzer sampling lines. We have another chimney thermocouple, and we have the stove internal thermocouples. Okay, so let me light the stove. We have a hopper chamber, we have a combustion chamber, we fill the hopper chamber with coal and it runs downhill into the combustion chamber where the fuel burns. And then all the emissions goes upwards to the upper plate and this gets nice and hot, so this is a cooking surface. What happens is all these thermocouples, you can see is the temperatures on here. And these temperatures is recorded in real time at every 10-second increments, and this is what you can see on the y-axis.
Ventru, thank you very much for sharing your passion and knowledge with us. See you in another day.
Thank you, Simon.
Mathematics plays an important role in every aspect of the work we presented. One of the tools that we need in particular is a way to forecast what impact of the different solution would be. We use mathematics to build a computer simulation of the real world that includes all pollution sources and the weather for a particular site. We can then include the plans to reduce contribution of different air pollution sources in a computer simulation to see if it will improve the air quality. First, we have to calculate the emissions from a particular source. Ngwabile Nkosi, a lecturer in geography at the Northwest-University Mafikeng campus, is trying to measure how much dust is caused by cars driving on dirt roads.
Hi Ngwabile, how are you?
I'm good, Simon. How are you?
I'm doing fine, thanks for asking. We can see that you're busy doing something here. Can you please explain to us what is it exactly that you're busy with here?
So Simon, have you ever heard of the phrase, it gets dusty in the township but windy in the burbs? So one of the reasons why it gets dusty in the township is because 80% of the roads in the low-income residential areas are unpaved. So what we have here is a series of dust tracks that actually measure fine particulate matter that is released into the atmosphere as the cars are passing by. We also have a traffic counter that measures the characteristics of the car, and then we have a mesh station that actually measures the wind and the temperature, the atmospheres, right? So what we're going to do, we're going to integrate all these data and actually find out how much fine particulate matter is released from their road as each car is passing by, so that we can be able to see maybe if we could pave the road, there's finding solutions, right? So if you could pave the road, we could reduce the amount of fine particulate matter in the atmosphere and possibly improve air quality in these low-income residential areas.
Wow, that sounds like music in my ears. That's very interesting. So, but how did you even get here? What ignited the spark for you of doing air quality? What were the subjects that you did?
Okay, so in my high school, I did mathematical sciences, I did physical sciences, I did life sciences, and I did agricultural sciences. So at varsity, I went in to do geography and biology. But then when I was about to go to my postgrad, I wanted to contribute towards the society by finding solutions to the problems that we have.
Wow, that is very interesting. Thank you very much for sharing your knowledge with us. So now we might have to pass on. Prince Chidindi builds a computer simulation of how sources contribute to air quality. He's a master's student at Northwest-University. He uses values that Nqobile calculates to forecast what the impacts on air quality will be. Hey Prince.
Simon.
How are you, man?
I'm good, how are you, man?
I'm doing fine. It's nice seeing you, man.
Oh, thanks, man. Yet you were on site with Nqobile?
Yeah, I was.
Remember what she was showing you about the cars and how much they produce when they pass a dust road?
Yes.
So that's the kind of information that I need to do my study. So the useful thing about mathematics is we can test things in theory while we are not doing it in reality. For example, an expensive solution can be done on a model before it's implemented. You remember what Nqobile is doing. Before even go and put tarred roads, we can do that thing on a model and we can find if the solution is right or is wrong so that we don't waste money on a solution that doesn't work.
Oh well, you gotta show me some of the predictions you've made, man.
Definitely, Simon. So this is a location that I used, which is Zamdela. You know, it's next to Sharpeville. So what you need is this, and then you find your sources. So each dot on this represents an area which is releasing particulate matter. And then with this information, weather and winds are being simulated by mathematics. And then from that, you get your ambient concentrations for the township, which shows the air quality over the township.
Oh, that's cool, man. So just for recap, are you saying we can use the mathematics to come up with solutions of air quality in the township?
Use your brain to save money. So yes, definitely. And I love what I do because it saves us the time and it saves us the money.
The work that you do is great, man. Thanks for sharing your time and your knowledge with us.
You're welcome, Simon.
Thanks, man. We have seen how to measure air quality, identify different types of air pollution sources, develop technology that reduces air pollution emissions, and we've also seen how to forecast air quality scenarios using computer simulations. Dan During is an ideal person to talk to tell us more about how these different topics that we've discussed work together in ensuring that we breathe the air that is clean and healthy, which is our constitutional right. Let's talk about how do government try to manage air quality.
Sure, Simon. So what government does is it sets certain rules. Okay, so certain thresholds in this case. For instance, with particulate matter, PM 2.5, they set a threshold of 40 micrograms per cubic meter, right, for a daily average, right? So it may never exceed that value. Then you are in exceedance of and in contravention of the law, right? Then there's other ways that they also use. They could regulate specific sources, so specific industries. There can also be emissions limits that they apply. And then they could also, for instance, require certain technologies to mitigate air quality impact. So basically to make sure that what you are emitting is not as harmful.
So let's talk about the work that you're currently doing. What is your research all about?
So basically what I'm doing at this stage is I'm trying to take all of this and make sense of all of these different inputs. And essentially, this should then lead to government formulating policy and legislation such as these ones that I've talked about, you know, these limits and these certain control technologies and these kinds of things to see which ones actually make the most sense. To formulate the baseline so that we know, you know, what the current air quality is. And then we have a range of different technologies that we can implement, and I can make these scenarios and projections for the future if I implement them. and then I can see what the air quality in South Africa will be in 5 years, or in 10 years, or in 15 years' time, if we act today. And with all of this, I can also look at the costs of these different measures.
So what did you study?
I studied a few things, actually. So I started with law, and then made my way into environmental law. And after that, I studied geology and chemistry, and then got into air quality in my postgrad studies. We need all kinds of people to solve difficult problems, and air quality is definitely one of them, and there's definitely a place for everybody in this field.
Ben, thank you very much for your time.
Sure, thanks, Sam.
If we look at the daily average fine particulate matter in Sharpeville again, and we include the South African National Ambient Air Quality Standards for the particulate matter, we see that there is a lot that still needs to be done.
Ms. Gabi Mkhatshwa, she's the president of the National Association for Clean Air. This organization plays a huge role in bringing together different people to speak about air quality related issues, as well as their solutions. Ms. Gabi, how are you?
I'm very well, and how are you?
I'm good. It's nice to see you.
Good to see you too.
So let's talk about why is it so important for different people to come together and speak about air quality related issues?
So we all breathe the same air. So when we have air quality challenges as a country, they cannot be solved in isolation. We need all role players and stakeholders to find platforms to discuss, negotiate, and talk about solutions. We need to work together towards a clear goal. And in this particular case, it would be towards cleaner or better air quality.
So what are those stakeholders, what are those exactly stakeholders that should come together and speak about these air quality related issues?
I'd say everyone, considering we all want to breathe clean air. And most importantly, we all have a constitutional right to breathe clean air. But ideally, the main stakeholders should be government departments, the likes of environmental affairs, health. It should be industries, academia, NGOs, NPOs like NACA, and the whole of society at large.
Gabi, let's talk about what is the role that NACA plays in ensuring that South Africans breathe clean air.
So you know how I talked about how we all have a role to play. NACA is a non-profit organization with a main aim to promote the cause of clean air in South Africa. So the role that we play is to act as a channel through which public, academic, and industrial players can share their opinions about air quality and communicate problems with air quality. We provide a platform for everyone, including air quality experts, to talk about air quality issues. We also have a team of air quality experts that are responsible for publication of a Clean Air Journal under the NACA umbrella. And on top of that, we host a range of platforms for scientific deliberations and technology transfer, including the annual conference that we have, seminars, workshops, and short courses that we offer.
So what do you think it is the role of scholars in fighting this issue of air quality?
I think the role of scholars is very important, especially because as young people, they have quite a big influence. Scholars need to get as much education with regards to air quality as they possibly can and get involved at ground level in community projects that promote clean air, and also with non-government or NPO organizations like NACA, where they can drive the purpose for cleaner air.
So what advice can you give to young people out there that are not doing anything in regard to fight this issue of air quality?
I would say it's your air. You are breathing the same air. And if we want to have an environment that is sustainably clean in the future for ourselves, for our children, and their children too, they need to get involved in community projects that pursue clean air. They need to educate their peers and their community members towards promoting clean air, and they need to be part of drives, outreach programs, social drives that push for a better environment and for cleaner air.
Thank you very much. I think that is it for this interview. Have a great day.
Thank you so much, Simon.
So at this point in my journey, I decided to check in with my course supervisor, Professor Wolof from Noordwes-universiteit, to explore where we are currently in finding a solution in improving the quality of the air we breathe in South Africa.
So Professor Wolof, what can you say we are doing in terms of ensuring that South Africans breathe clean air?
Well, we have made huge progress in understanding the problem, knowing what is the sources that contributes to air quality. However, if you look at how air quality is changing in our cities, and you know, for example, in Sharpeville, the picture isn't very bright. There has been no significant change in air quality over the last few decades. You see, the thing is, if you just wanted to find out who the culprits were and close them down, it would be easy. We could close down the mines, close down Eskom, air quality would be better. But the problem is we need the mines, people need jobs, we need electricity. So we need to find this balance, finding solutions to improve air quality while growing the economy, making sure people have jobs. And that is the challenge that we face. So yeah, it's not only a good story.
So tell us, how can young people, especially young learners, contribute towards ensuring that we fight this issue of air pollution?
Well, you know all about it. The only way we will fix this very complex problem is for people to take the time and effort and focus on this problem. People like you, who will dedicate quite a few years of their lives to study, to become clever, and to understand, to have a deep understanding of the problem. And only at that point can they contribute to the solution. So that is what we need. We need young people to take on the fight and educate themselves so that we can make sure we have a better future.
So what specifically should those young people study?
I'm sure when you speak to all the people, you get an idea of the breadth of disciplines that we need. It doesn't matter if you like geography or maths or science or history. We need people from all these different disciplines in order to solve the problem.
So please, can you tell us about your academic journey? What did you study?
I loved mathematics. And then I studied atmospheric science, and now today, even though I didn't even have geography at school, I am a geographer.
Thank you for your time, Professor Wolof.
Thank you, Simon.
Have a nice day. Air pollution, it is the biggest environmental challenge of our time. One that we don't often see or even speak about. Science, technology, engineering, and mathematics can be used to provide us with useful tools to solve it. Our situation in South Africa, even in Sharpeville, is unique. Therefore, we can't buy solutions from United States, Europe, even in Japan. We need to build them ourselves. Up until now, you've heard my story, but air pollution, it's your story too. So let's work together in creating a better and cleaner future for South Africa.